Some of my code still flies in A380s and 777.
Wow.
This is a key learning curve for developers. Certain technologies which enable you to go live very fast, backend, frontend both. But at scale, you need those things actually come in your way. In finance, the inventory is always bound with a price point. If you see, let's say Reliance, and you see it at 2,000 rupees, you want to buy Reliance at 2,000.
Yeah,
right? Not 2001.
The sticker changes very rarely.
Right? So you send the order at a particular price point.
Yeah.
Then you need to figure out how much money, or what we call as margin, to actually deduct. So that is done real time based upon the same UDP feed at the back end.
So how do you look at infra?
I have a healthy distrust of a black box.
Okay.
So if there's a black box, I know someday it will bite me. From senior engineers, right?
Yeah.
We expect a certain way in a way they go about exploring the problem and the solution. You generally need to go from the why to the what and then to the how. We ask questions like, why did you choose a funky new database versus a traditional database?
Okay.
Most people say, I read it in a blog or something,
Yeah.
which is not the right thing to do.
Hey, hi, this is Arnav. Welcome to another episode of ScalerPod. Today I have for you Jyoti. So Jyoti is CTO at Angel One. He's also pretty well known in Python and Go circles because he's written a couple of books. So first of all, welcome to the show.
Thanks, Arnav.
Okay, so I'll get started with my
First icebreaker question, which is, I ask because there are CTOs from companies of very different times in their life cycle. So I love asking this, that what does the work week of the CTO of Angel One look like? What are the things that you are responsible for on a day-to-day basis?
Interesting question. So the work week, as I said, it depends on the life cycle, on where we are in the journey.
Yeah.
Today, most of the time actually goes in 3-4 fronts. One is operational excellence. We roll out a lot of features, and we want to make sure that, and reliability is a feature. Reliability is a P0 feature for our customers. So how do you make sure the systems, while we release at high scale, still stay reliable, right? So a lot of time goes in the operational excellence time, reviewing dashboards, reviewing PRs, some critical PRs, doing RCAs and stuff like that. The other part is we work a lot with product and business teams on crafting new features. So basically understanding the why of the problem, what they want to do, and then of course working with engineering teams to figure out the how, right? And I generally don't get involved in the how. So my main job there is to ask tough questions to the product and engineering folks.
Right.
And the last part is obviously working with people. I am an enabler at the end of the day. So making sure that the people are happy, excited, and are invested in the vision that we have, that they connect to the customers really well, is something that I keep tabs on.
Right. So I'm gonna come back and ask a lot more questions about what all tech goes behind the Angel One platform, because I'm
Sure.
myself very curious about it. But before that, I would love to take a journey down the memory lane and ask you a little bit about how your journey in tech has been so far.
Sure. So actually, I started coding pretty early, and in 7th grade, I remember my father was a chemical engineer, and he had this PCs at home.
Okay.
The 486, 386. This is
Yeah.
91, 92, and he had like engineering drawing programs, and I used to play around with them after office hours, like just play games mostly. And so my father asked me, if you're spending so much time, why don't you do something useful? So at that time, we had like DBase 3 Plus. And Lotus 123, like those kind of applications, and you could build simple apps on top of them. So I started building apps, the unique programming constructs, like very similar to the basic language, if you heard about it.
Yeah.
So I started coding up simple apps for my father, but it was basically fun, right? Till actually I started playing a game called Doom. I don't know if you heard about Doom.
Do I have? Yeah.
So and when you come from the earlier games and you saw Doom, it was an eye opener for me. I was blown away by how fast they could render the 3D environment around the player. And before that they were like had if you played Prince of Persia or Mario,
Yeah.
they had a very 2D kind of static scene. And here you could actually navigate through a whole space. And there was no literature about what they did. At least I didn't have any access to that. but I saw that a lot of logs there's to print out. So I got fascinated by that. And it was then I started learning C, because I to understand what those logs were and try to understand that, and that got me hooked. So so I was always into some sort of hacking up code and trying to build stuff, and computer science turned out to be the logical thing to do. And again, when I started learning computer science, the theory just got me hooked. And the base maths around it, the theory of computation.
Yeah.
I don't know if you heard of Gödel's incompleteness theorem and stuff
Yeah.
like those. Those really got me hooked, and I found this domain fascinating. Yeah, so when I finished engineering, I wanted to do something which was close to coding. I didn't want to get into a consultancy shop. And so I picked up jobs where I could actively craft things, right, and which were more or less R&D shops rather than consulting shops. So first 10 odd years were spent in what we would call low level systems programming. So I
Okay.
worked on everything from radar collection software. So you got multiple radars giving you inputs. How do you give a debounced combined view
Okay.
to flight control systems? So some of my code still flies in A380s and 777.
Wow.
And in Microsoft, I worked on the Windows operating system. I also worked on the first code base of what is now Azure, the hypervisor which is now Azure.
Yeah.
So this is about the first 10 years. The next 10 years, and from systems programming, I typically gravitated towards distributed systems and the like. So the first startup I did was actually a file system on top of plain EC2. This is 2010. And that time Amazon had come up with EC2, and it was a game changer, right? You could have compute, scalable compute as you go, but there was no place to put data. So if you have a big like a database in your private data center or a NetApp file server, there was no way for you to get that data into AWS. So people used to just connect back to the data center, and that was very slow for, as you can imagine, you're going over the wire for going across data centers for every database access. So we built a startup, and that got acquired, and it turned out to be one of the first cloud native file systems. From there the journey started into e-commerce and all. So for the last 15 odd years, I've been into, I would say, e-commerce, various variants of e-commerce, whether it's travel, retail, or now finance. So yeah, that's been the journey so far.
That's quite a journey, because I think software which you ship like firmware, and which typically like stays running for 30 years, versus these days consumer software is you can just push out an update every day, continuous deployment world. It's a very different world, right?
Very true. And especially I think my biggest learning was when we did software for flight controls, in the FAA. I mean, this was for Airbus and Boeing, right?
Yeah.
And the FAA there is very very particular about how you've done tests and all those audits, right? So you had to write code which was nearly impossible to break. And doing that is quite difficult, right? So imagine a control system controlling, let's say, cabin pressure.
Yeah.
I mean, a slight reboot will not work. You need to make sure that there are two active systems, always making sure that the cabin pressure stays at the right levels.
Right.
Otherwise,
everything is mission critical, basically.
Yeah, everything is mission critical, right? So that got that is something you probably don't learn in college.
Yeah.
But that was a good experience to learn that.
Nice. So, coming to, I think you said you spent a lot of time in e-commerce. We were just talking just before this, and you said that something like Angel is also commerce. How do you see something like finance products from the lens of commerce?
So if I look at a e-commerce or a B2C app, right, there are a few funnels which are very common. So you have a discovery part of the product, where people discover inventory, for lack of a better word, pricing related to inventory. Then they get to a details about the inventory.
Right.
Like for example, e-commerce, it might be details of a shirt which you like. For a stock, it's like a stock, you want to see the fundamentals.
Yeah.
You want to see a price chart of the product, and then you get into a actual fulfillment part of it. So e-commerce, you probably check out a cart.
Yeah.
Here you buy the stock, and there's a post fulfillment flow.
Right.
In e-commerce, it's basically getting the goods into the hands of the customer.
Yeah.
And in finance, actually, it's a pretty involved process.
You
So
want to see your portfolio and all of that stuff.
you want to see, so once you buy and sell, the order is actually placed with the exchange, right?
Yeah.
But actually transfer of shares happens with the depository,
Hmm.
which is orthogonal from the exchange.
Right.
So immediately after you did your fabulous transaction, you want to see your profit and loss. You want to see the stock in your portfolio if you bought it,
Right.
or if you've sold it, you want to withdraw, let's say, the money for something else, right? And there's a lot of hand holding that happens between the broker, the exchange, and the depository.
Right.
So those can get pretty involved. Right. And at the scale which the ecosystem is exploding, new regulations keep coming up.
Yeah.
So we need to kind of handle the scale with the new things as things come up as well. So while I would say and I did travel as well. So so all of them have unique quirks, but I think they have the same funnels, and you can use similar ideas across the platform.
Right.
Right. So that was pretty fascinating for me.
Interesting. Any particular example of some, like let's say a travel OTA or a e-commerce problem statement that you see gets
Sure.
solved in a similar way here?
Yeah, so let's talk about travel, right? And so travel, two main things that people care about is flights and hotels. We'll talk about both. Very interesting problems, right? So in flights, the inventory is not owned by the e-commerce company, right? The inventory is owned by people like, say, like Indigo, and there are also some aggregators, like the aggregators talk to different other airlines, and they provide you they own the inventory for the other airlines, right? So when you search, let's say, Bombay Delhi flights, you are actually talking to a bunch of different airlines and getting their information and serving it up, right? So it's basically a very parallel thing that you're trying to architect. And obviously, if you take a minute or so to show your search results page, it's not a great customer experience.
Right.
So how do you, one of the first problem to solve is, how do you get a responsive search results page, even if one of your dependent systems are not that performant, or if they're down, right? So you need to build some sort of timeouts to guard your SLA. Right. So this is the first thing, right? So you have an in-memory scatter gather of all the different prices. You have a timeout for when the search will complete, and whatever you have, you return.
Right.
And whatever is late, you probably do a delta update to the search page.
Yeah, that happens on the UI also. It is visible sometimes. Correct. Like some results come and then others keep populating.
Right? Yeah. So that was, how do we do it, was one interesting problem. The other interesting problem is, you generally don't have a point to point for every city in India. Let's say you're going from Bombay to Meerut.
Right.
There won't be a direct flight, right? But what you can do is, you can go to Delhi, and from Delhi you can go to Meerut, right? So how do you infer that you have to go to Delhi? You have to search Bombay Delhi and Delhi Meerut for a Bombay Meerut flight query.
Right.
So it's a graph problem. So if you want to build it in the most pure form, then you would model it as a graph problem and see the shortest path between the two nodes. But the graph traversals are slow. So we built a unique algorithm where we knew that there were core, I would say, hub nodes like Bombay, Delhi, Calcutta, Hyderabad, right? And then you knew that each hub node had connectivity to certain spoke nodes.
Okay.
So you have to.
So, but even airlines use a hub and spoke model, right?
Correct. Yeah. Even physically, they use a hub and spoke. So we built a graph which had this kind of one edge nodes. So you could figure out between Bombay, Delhi, and then you can, for example, in Meerut, you can figure out Meerut is closer to Delhi, and Bombay, Delhi is a hub. So let's say if you went from Pune to Meerut, and you figure out Pune is closer to Mumbai as well.
Okay.
And then you build this graph connections and basically build the itinerary. And this was done in milliseconds, right? Interestingly, the same algorithm is used in graph databases. Like, if you have similarity search between, basically you have a vector space and you have a point and you have to find the closest point around that specific point, right?
Yeah.
Like like what vector databases do today. So they use something called as navigable small worlds, where it's basically a very similar concept. You go to the hub which is nearest to the point. From the hub you figure out which is the point which is nearest to the original point.
Right.
So instead of doing a ON computation, taking the point and matching them with all, you just map with the hubs rather, and from the hub you figure out what is the closest spoke. It doesn't give you the perfect answer, but it gives you an approximation which is very good, very fast. So that was the problem to solve with Flight. It was very interesting coding this up. We used Go. We can talk about it in a bit, and we were and the inspiration to use Go was like how Google does its search, right? If you search cats, it'll search web, videos, images pretty much in parallel, and you have a timeout of giving back the results, right? Modeling this code in Go is very easy, right? And so that was the reason it was pretty good.
Nice.
Hotels was slightly different. So the hotels, the query you typically to start off with, you give is, let's say I want to see hotels in a city with a specific check-in and a checkout date, right? And again, the inventory is owned by a multitude of different hotel operators, right? And they keep changing availability and what type of rooms are available and all that. And if you do a naive search, with the city, and you have a check-in date, checkout date, you will have to go through a whole bunch of rows, database rows, to actually surface a search result page. Imagine searching in Bombay.
So many hotels.
Yeah, you have 10,000 hotels. You don't want to search all the 10,000 hotels for a check-in date, checkout date combination. That's going to be extremely slow. So we pre-computed for every city. We had like a few top hotels. For every hotel, we pre-computed check-in, checkout combinations, and then we stored them in a database.
Okay.
Right. So once the availability comes saying 24th March is unavailable, then we pre-compute.
Basically, all possible views you are
correct.
calculate.
All possible views, right? And we knew that logically people ask for like 5 days, 2 days, 3 days, 4 days. People won't ask for 15 days, right? So pre-compute those, store them in a database, and then serve them results very fast, because your key just becomes Bombay, check-in date 21st, checkout date 23rd. So that becomes a key. You instantly go into a database, look up the results, and send it.
Got it. If somebody still searches which is not pre-computed, then that will be slow.
Yeah, that will be slow. But that's basically you're solving the problem for 90% of the people.
Yeah, that's the 10% case.
Exactly.
People will face that. Interesting. Coming back to let's say a brokerage platform which you are running right now. So recently was teaching a bunch of engineers, and then some of my mentees and all. One of the things I've seen is that with, let's say, a food ordering platform or a shopping app, it's because you can also, when you're teaching, let's say, backend or frontend, you can even make them build a side project out of it, and it's more tangible in your mind that what is happening, that okay, there's a database of products, product IDs are there, you make an order and purchase and all of that. Obviously, like the physical part of actually delivering something, that's I think that's operations, but the tech part for people who have not actually been part of it, it's still much easier to imagine. With finance products, especially for example trading, what do you actually see in your app or website? I think somebody just sees that okay, I have an account which has balance and I can buy shares. Like you were talking about that, where I am searching for the stocks is the exchange where my order gets placed with the exchange, but where I get my stocks is the depository. I mean, this part, if you could expand a little bit more, like under the hood, what all things that tech is doing, because to you as a user on the surface, it's actually like buying digital goods, right? You purchase and then you have a shelf where you are putting them, And you can go and sell it back again, and you can always look at your shelf, which is your portfolio. And I'm under the hood, obviously the tech is a bit more complex. So if you could give a laydown of the feed.
Sure. Let's go by step through the journey once you log in, right?
Right.
So once you log in, one of the first things you see is a watch list of your stocks of interest. Correct. So there are some stock names and basically prices against each, right?
Yeah.
Stock I'm using liberally. It could be any instrument,
Any
like
ticker,
option,
got it,
any ticker, right? And then you got prices against it, right?
Yeah.
How do those prices actually reach the app is the first problem to solve.
Right.
From the exchange, you get a UDP feed,
Okay.
right? And it is a fat ticker, so you get about 10,000 price points in a second in a one packet.
Okay.
And then we as a broker need to distribute this price point into whoever is viewing that particular stock.
And the exchange ticks every second.
Every second you get actually it's not a per cadence tick. Whenever there's an update,
okay.
Whenever there's update, they give it. This is just an indicator. Yeah, we have to listen for it, right? And UDP is the fastest way to get information across.
Yeah.
So that's how we get
and
it.
even if you miss it, it's okay. Next tick you will get.
Exactly. The next tick is more important than trying to get back the actual price, especially for high ticker items, right? So it's a basic WebSocket, and the way we serve prices to the apps is through WebSockets. Right? When you open up your watch list, you have like 5 stocks. We subscribe to those 5 stocks onto the backend, and this backend, what it does is basically routing. At the bottom part, it listens to this heavy feed, and on the front end side, it has a bunch of connections. One of his Arnabs, where he's looking at 5 stocks. So basically, it says, okay, these 5 stocks I need to pipe to the front end.
So everybody who is on the watchlist page,
yes,
has an active WebSocket connection.
Correct.
So you need a lot of nodes which will host these WebSockets, right?
Correct. So what you need is a really fast router. Right? And also you need aggregated information to be sent across the router. Right. So if you look at a typical view, you will get like what is the current price, and if you double click on things, you will get what are the top buys and top sells.
Right.
In buys are sorted by the highest to lowest, sales are by lowest to highest.
Yeah.
So this is how basically you're trying to model an exchange. What is happening in the exchange, right? Or what is in queue of the exchange? You're trying to model it on the app.
So the data of the pyramid of the bids, that's also coming over that UDP channel from the
exchange. It's coming over the UDP channel, but we need to construct the data structure ourselves. So we have like a balance trees where the price updates keep coming. And we reshuffle the prices, saying what is the current lowest price. It's basically a sorted list, right, on both sides. And then we do some few aggregation like total quantity, how many total people are viewing, stuff like that,
right?
And that we actually pipe it to the app, and we need to do it per client. So we got like 4 million odd connections. You got a feed at the bottom, so you have to route things really fast. So it's an in-memory router, so this is the first part, right?
Typically for your scale of data that each client is taking, how many active connections do each of your nodes support?
So that's a great question. So we use Go, right? So with Go, a 64-bit machine typically can have like a 500,000 connections odd, so we have seen connections grow up to 4.5 million at any given point in time. Total
number of online people.
Total number of online active connections, right? And they change based on what you are doing in the app and stuff like that. But we have seen peaks of 4.5-5 million active connections, right?
Yeah.
And the key thing here is you need to make sure that you ship the latest price as soon as possible.
Yeah.
Because if you're watching the tick, you need to see it update.
Yeah.
You don't want to see a later price. And things can get pretty complicated with something like an option chain. Option chain is basically you're weighing the same instrument, and they have multiple expiries. You're seeing prices at various expiry levels. So in a single screen, you got about 300 moving numbers at a very simplistic level. And those moving numbers you need to pipe from the UDP feed right up to the app as soon as possible.
Right.
So that itself is a pretty big challenge. WebSocket connection management is a problem. Because connections do die, flaky. You need to reconnect. When do you reconnect? So that's the first part. once you in discovery, once you see a instrument that you like, you typically go into the details of it. Like you see a chart. When you open up the charts, you see the prices over a time period. It could be the last 1 week, last month, or last 5 years. So, and then what typically people want is, along with the historical updates, they want to see a real time update as well. And so they see bars for last 5 days
And then
and the
keeps
current bar, and
updating at the
it
end.
keeps
Yeah.
ticking.
Yeah.
That also is a pretty interesting problem to solve. And to your point, there are companies built just solving those. So very
I
successful.
think,
Trading View.
TradingView, yeah. I think most apps use an
most
SDK
use
only.
it, correct, on top of TradingView. But TradingView by itself also is a separate product.
Yeah.
So just getting points and showing the visualizations very
Yeah.
quickly itself is a great engineering problem. So we
Yeah.
we went with a time scale, with the time series DB, and we switched over to getting a different stack to get those performance up. So that also is pretty involved.
And the client is
Yeah.
also challenging it, because you need to have those zoom in out functionality in it as well. And
Correct. The client is also complicated, and the client also needs to keep an active WebSocket connection to keep updates.
keep updating it.
Yeah. So let's say, for example, you're watching the prices over the last 5 hours, and you go into, let's say, Instagram, and you come back into the Angel One app. Now you got like 5 minutes of where you are not watching.
Yeah.
Not watching the chart. So the WebSocket has not updated the chart. So if you build it naively, you will see a space between the bars.
Because the backfill won't be there.
Backfill won't be there. So
Yeah.
you need to refresh
Refresh the historical and then
data.
start the updates.
Exactly. So how do you do that?
Right.
And on a web, it gets even more challenging.
Yeah.
Because Chrome can, Chrome, even
Oh, the
iOS,
tabs can die and all of that.
tabs can die. Chrome makes its own judgment on whether the tab is visible or not.
Yeah,
If so,
background.
if so, pauses the WebSockets. So handling those itself is a pretty, it's a thing that you learn, and it's you need to get right pretty well.
So this connection management on your client apps, is that done using some web code like React Native, or is it done using native
So
itself?
so for all this, right, we need very good performance in the networking side of things and in the reactivity side of things.
Yeah.
When I mean reactivity, so in a typical front end, what you do is you update a store, and there are many views who subscribe to the
and the
updates
view
of the
updates and-
exactly, right? And they update themselves. This is a
Yeah.
pretty common programming model, React. That's the name.
Redux based
exactly.
Flux architecture kind of things.
Exactly. And that's pretty much in the all native and other places as well. What we saw is, to really get this reactivity, you need to be as close to the wire as possible.
Right.
So for example, that means for the mobile apps, we need to use native
networking libraries you have to use. Native.
Yeah, you have to use native construct as much as possible.
Right.
Similarly, on the web, React didn't work out for us because the virtual DOM updates were very slow.
Okay.
We tried React, we tried Vue.js as well. In even Vue.js, the subscription updates.
Yeah, if you make too many observers, at some point it starts becoming visibly slow. Yeah.
Exactly, because it's a single loop. Basically what the runtime is doing is just looping through all the observers and telling each observer, hey, here is the new update, which makes the whole view sluggish to update. And
that's an interesting thing. I have always felt whenever I've been teaching front end, I've seen this interesting thing is that whether it's React or Vue, or even these days Swift UI, or this Compose, Jetpack Compose in Android, the getting started itself, like you do the 101 level article, it will show that, okay, there's this data object, and you just put it in your view, and you change it, and it will keep updating. So as a beginner, you're not exposed to the fact that, under the hood, everything you have to create a listener. You have to...
Correct.
Like, there is no free lunch here. Like, there are no observers in the actual computing model. There is no observer.
Absolutely.
Somewhere there is a listener, and every time, like, on change, some function is getting called. It might be hidden away from you. What is happening? And if you use that kind of observing construct 500 times in the page, obviously, somewhere something needs to loop through 500 items and call those functions.
Absolutely. And especially if you have composite views. Right, if you have composite views where the same item is updating one panel, let's say watch list, and you're watching a chart, right? So one of the common views is you have watch list and you have charts for each. and you click on the second button and the second stock's charge pops up. And there's real-time update here as well as on the watch list panel. And each is a different subscriber to the same update. And it's pretty visible if some panel starts ticking more faster than some other panel.
Because it'll look very odd to the eye that this is going faster, this is going slower.
And in lot of this heavy dynamic views, the abstractions that actually give you the fast 101 go lives actually start breaking, right? And this is key, right? This is a key learning curve for developers. I think that there are certain technologies which enable you to go live very fast, backend, frontend both. But at scale, you need to those things actually come in your way.
How to go down to the metal?
You want to go down to the metal, right? So and it's not that we've just not used it. Like for example, we have a lot of cross-platform UI elements where there's no so much reactivity needed. For which we just settled down on two things: native and web views, right? So web views allow you the cross-platform usage,
single code
base. You release very fast. You don't have to release an app and stuff like that. It gives you a pretty slick experience.
Right.
Where you need performance and the reactivity performance and a long list and all those, we stick to native. So that's been our stack.
Even like a huge JSON, like a 500 KB JSON. Parsing it and rendering it on the screen, there's a visible difference in doing it with native versus with a hybrid technology.
Exactly. And it doesn't show up in the, as you said, the smaller JSONs or smaller lists. Right? If you have an Android recycler view and let's say a React Native equivalent, if for like 100 odd items,
for a dummy list you make for a side project app, it does not make a very big difference. But when you have the 1 MB, 2 MB size JSONs, it starts
exactly. And if you just scroll the smooth scrolling experience, you can make a visual difference there, right? So I think you choose horses for the courses. And so that's what our stack has been.
So that's about the trading within the next step.
The next step after that, let's say you want to buy and sell, right? So what you do is actually, the first thing is figuring out how much to pay. That itself is how much to pay for the inventory, because here in finance the inventory is always bound with a price point. If you see, let's say, Reliance, and you see it at 2,000 rupees, you want to buy Reliance at 2,000. Right? Not 2001.
The sticker changes very rarely.
Right? And you want to buy it at 2000, not at 2001 or 1,900 or whatever. Right? So you send the order at a particular price point. Then you need to figure out how much money, or what we call as margin, to actually deduct. So that is done real time based upon the same UDP feed at the back end. The feed is also used at the back end to figure out how much money we need to actually deduct from your available margin.
Right. So when I place the order, like the price I'm seeing, when it finally gets placed, obviously the ticker would have moved.
Yeah, exactly. So we try to get you as close as possible to the price point. Right. And there are variations on this. And if you're doing options and margins, you can come to margins as well. Right. And then the order gets placed to the exchange. Right. The exchange just gives us a 201, in the HTTP REST API parlance, accepted, right? And then there's a whole asynchronous process of updates that come in from the exchange, whether the order is queued, the order has been executed, cancelled, or whatever. At the exchange side,
so for that order ID, you keep getting
keep getting update, and the order ID is actually the ID that also is an interesting problem. Because the client can retry, your app can reboot. So how do you make sure that we debounce the similar orders instead of placing one order for Reliance? How do you avoid placing two orders? So we generate an ID right at the UI level, based upon few characteristics.
Some UUID kind of thing.
A UID we generate right at the client level, and then every time you retry, the same ID is passed back down, and that ID goes right up to the exchange.
Unless if you create a new order fresh from the UI, then it will be a new.
Correct. It depends. Exactly. It depends on the UI flow. If you go back.
But the same order, if you press retry, it will have the same ID.
Same IDs. Or if the UI is programmatically retrying. Because it's making an API call. Right. And the API call might fail. The UI code
this itself, ID, like through your systems, it's like an X-ray ID kind of a thing.
Exactly. Right. And, and the exchange then gives its own ID back. Saying, this for this ID, this is my ID. We link those. And then we keep getting updates back.
And these updates from the exchange, like, because on your system already millions of people are placing.
Yes.
So these updates, are you listening in batch or bulk, or for every order you're listening separately?
So there's a feed channel, right?
Okay, so all the orders you have placed, you are getting updates.
You're getting updates on the feed channel.
Okay.
And to make this scalable, we have sharded our the entire systems, the core trading systems, right?
Yeah.
So instead of one box serving all the customers, we have like multiple boxes, and the orders go to different groups of this core trading systems.
Got it.
And all of them have independent connectivity with the exchange. So this is way we shard it, and that becomes.
But you need to take a fixed set of lines or something from the exchange, right?
Yes. So that's the core infra. So we have multiple lines of exchange now.
Okay.
So each of the shards, right? With the exchange. So if your order goes into, let's say, shard 1, the exchange will reply back on the same line which is connected.
Shard to shard 1 will observe your order updates.
Exactly.
Got it.
Right. For me, it's shard 2. Then my connectivity is on a separate connection. So this is how we scale performance and responsiveness, and also
reliability. Also, because one of your shards can go down.
Exactly. And that is a unit for disaster recovery as well. So that one shard is something that we actively replicate in a remote data center.
Okay.
That itself is a complex problem. We can talk about it later. But so that's a concept for DR. And so now you get the updates back, and then once the update comes back, then on a different WebSocket we keep updating the app. Right. In normal days, all of this is milliseconds.
Yeah.
Right. And you just see you placed an order,
immediately
you say succeeded or whatever. Right. But behind the scenes, there's a lot of in-flight things that happen. Now things can get complicated, when we give things like margin to customers. So with margin, what happens is typically with, let's say, 20,000 rupees, you can buy 1 lakh worth of shares. Right, and you do that by pledging 1 lakh worth of some other stock that you have. Now that other stock of yours, on a not so great day, could fall and depreciate. Right. So we have some pre-flight checks to make sure that you have your collateral, whatever you pledged, is worth the amount that you're actually
goodwill
buying.
In your collateral.
Yes, correct. That's where we have pretty complicated risk management systems, and those are like a domain of its own, right? It's like, how do you quantify? Like they're all probabilities. A lot of probability equations keep happening. Right. And we look at not just you. We look at, or not just look at your immediate order. We look at your entire portfolio, and what is the probability of loss in the next 2 minutes or in the next day for the entire portfolio. Okay. Based upon that, we figure out that you need some more money to place. So these in-flight checks keep adding complexity to the margin check that we talked about.
And these orders can also get partially fulfilled, right, on the exchange? Correct,
exactly. So you are lined up in a queue at the exchange, right? And the quantities might be different. Let's say you are buying 100 stocks, but on the sell side there might be a 50 side chunk.
So the 50 gets matched, and then the next 50 for the next year.
So and all of them come as delta updates for us. And then we keep surfacing it up back to the UI. And that itself is an interesting problem. How do you show average price?
Because your single order of 100 might have actually been bought at different
prices. Right? You, for example, people also have this market price thing. You basically say, I want Reliance no matter what the price. So you put a market order.
Market order, and then there is a
and there's a limit order. Saying I want at a specific price. So and then you sell probably some of those shares as well. So that matching, to figure out your average price is also a pretty involved computation. So that happens at one of the backend systems which updates your positions and portfolios. What is the actual average price? So anyway, coming back to the flow. So the exchange, let's say your order succeeded. Right? Now for the actual transfer of shares happens later. Right. So typically on the
day, right?
Actually at the end of the next day today.
T+1.
T+1. Right. And there's some stuff in flight to make it T on the end of the day. Today it happens at the end of the next day. And between today and end of day tomorrow, there could be various things that can go wrong.
If you buy and sell it within the same day, then it does not need to be transferred.
It does not need to be transferred. We're talking about delivery where you want to shares, right? So you can think of it, right? If there was no CDSL or a depository, then brokers would have to handshake between them.
Yeah.
Because you placed order on Angel 1, someone
Yeah.
else placed an order on broker X, right? Then Angel 1 would have to talk to broker X saying, give me those shares,
Right.
and then I will give it back to Arnab.
Yeah.
Right? And that end-to-end mapping is very difficult because
Yeah.
broker X could go out of business tomorrow.
Yeah.
And then you'd not be a happy soul that where is your $1 million stock.
Yeah.
Right? So that's why they are this called depositories. They're
Yeah.
a single point where all the brokers kind of send out their orders, and then
They're the custodians.
they're the custodians exactly of the instruments. They do the matching and then they send it across.
Right.
And for the exchange and the depositories, the entity in question is the broker. It's not Arnab as a customer.
The broker is the person through whom the
orders come. Like, so what those two things work in terms of settlement is how much shares do I need to pay Angel, how much shares do I need to get back from Angel, how much funds do I need to give to Angel, how much funds do I get back from Angel.
Right.
That's all they do. Right, 4 things.
Yeah.
And then Angel has to divide it out among all the customers.
Right.
Saying, okay, Arnab bought this. So there's a whole bunch of accounting things that also get done after the market closes.
I love one of the interesting things I find is a lot of the terminology is carried over from the physical days, like cash and carry, for example, actually means that you carry your share certificates home and all of that. But now it's all digital, but some of those terminologies are
still crept up. Yeah, exactly. Right. Yeah. So even some, so it's heavily digitized now.
Right.
But the fulfillment part of it can get pretty complicated. Different challenges from a retail or a travel space.
Right.
But so on to your other question on how people can innovate without investing in the core infra, right?
Yeah.
So the core infra here is obviously the lease line with the exchanges and setting that up, right?
Correct.
But on top of that, many people, including us, we offer APIs.
Okay.
We plain REST APIs where you can buy, sell orders, subscribe to the feeds, etc. And you can build experiences on top of it. And there are many cool apps which have been built on top of the APIs. Okay. So you don't need to invest in the core infra as such.
Yeah, like I think I've seen some portfolio analysis apps are there.
Exactly.
You can plug into Angel and see.
Yes, exactly. So we have hack days. So one of the recent thing where we built was to actually build a correlation between across instruments. Let's say you feel that if HDFC goes up, you want to buy Kotak as well. That's your brilliant strategy.
Okay.
Right. And you don't want to keep coming to the app every day because customers are busy and they don't want to keep saying, right? So how about I say just that? And you just tell the system that if Kotak goes up, I'm expecting HDFC to go up or vice versa. And so I just buy HDFC. That's all you say. So you underneath you have a system which looks at all the feeds, which takes your authorization, and churns it up to see the predicates match, and it can be a very big Boolean predicate, right? And then basically places the order for you. So I think that's the future, honestly, because I don't think people are just going to stare at screens and
they will have probably with AI and all, maybe creating agents and all.
Yeah, exactly. People don't have time.
Scripts, I think, have been popular for a while already.
Yes, scripts are there, but this building this predicate engine at scale, that is tough. You're building at a very high volume of data,
right?
And then evaluating all those rules and then executing. But you can do it without investing in the infrastructure. You can build a add-on experience on top, and there are many good examples like Streak, Sensible. So they have built experiences on top of the core infra.
Right.
So there's space to innovate there.
Got it. One thing would love to talk more about is like the tech stack itself, and I've seen you have written about and talked about also in the past about using Go for highly concurrent systems, right? So right now a large part of your backend is Go, right?
Correct.
Yeah. So I mean, why Go as a choice for something like a trading backend? What have been the benefits, I would say?
Sure. I mean, we can look at various attributes of the choice, right? So the first one is efficiency, right? When you are dealing with a lot of concurrent requests, in a typical Java world, you would have a request, a thread per request model. So you would have a thread servicing a request, and so on and so forth. In some of the examples we talked about, where you want to have a parallel computation, even there you kind of spawn parallel threads, and then do a composition or wait on the results and give the results up back, right? See, in every programming languages, the basic unit of programming concurrency is a thread, but it's all about how the thread is actually engineered underneath. For Java, a thread is a OS level thread. Right?
It's a one-on-one.
It's a one-on-one mapping.
Right?
So what does that mean? So in a typical 64-bit server, right, Java thread size is about 1 MB. Right. So in a 1 gig kind of a machine, a RAM, you host about 1,000 threads. That's it, right? In Go, it's a different take on threads, right? So in a Go, a thread is basically a user space construct. It's not mapped one-on-one to the OS thread. And the Go runtime actually manages execution of individual thread onto each actual thread, underlying thread, right?
It has a compiler level scheduler in
it's a runtime. It's a runtime which schedules the threads onto each of the threads. And generally the way we do is, you have as many threads as number of cores. If you have 4 cores, you have 4 underlying threads, and each Go route is scheduled on the underlying thread that Go runtime manages. And the stack size starts from 2 KB. And one thing about Go is, it expands and shrinks the stack as memory is used, is moved. So you never run out of the memory. People think, what happens if I put a 5 KB variable on my local variable, right? It will push on the stack, but before it's pushed on the stack, there'll be a check, and the Go runtime actually expands the stack. It's a pretty cool thing to use, difficult thing for the runtime. In fact, there have been 2 changes in the internals on how Go implements this. But for a programming model, that's super cool. So coming back to the original example, right, on a 1 gig 64-bit machine, that means you could have like 500,000 threads. 500x the capacity that you can get from one single server from Java versus Go.
Right.
And that means the program, since there is so much capacity, the other part of how we really love Go is the simplicity. The way you code up a parallel computation is inherent. There's a very standard pattern, and you just use that pattern. Right? And this is the other thing about Go, right? It's very opinionated. Right? So the whole language is pretty easy and simple to learn. It's about 45 pages of the total spec. So for example, there's no while loop. Right? There's no while loop. There's a for loop.
Just one type of loop.
One type of loop. So running static analyzers, code reviews, how to do good, how to write this in the right way.
Formatting is also part of the language.
Formatting is part of the language. Right? So it's very easy to use. Versus Java, where you have multiple choices. You have reactive Java, you have got parallel stream, whole bunch of ecosystem around Java, right? Whether you go with the Spring world, the Vertex world, and you really need to understand that very well to take it to production, right? And that involves a lot of investment, in figuring out in performance management and stuff like that. Whereas, as we talked about in Go, it's close to the metal. Right, there's no and
native
binaries, and it's very opinionated. So the choices are restricted. So that means you going wrong as a programmer, and moving fast is also less.
Right.
So that is something which we really love about Go. Just an example, right? In Java, they have multiple versions of this, right? So they release something called as parallel stream. One of the Spring constructs, where you can say you run this function in a parallel, in a concurrent way, fan out way, and then if you have 5, for example, then you run the same function 5 times in parallel and get back the results. And the internals of those, unfortunately, the defaults are not great. So they use a common executor pool,
Yeah.
and the size of the executor pool, if I remember right, was the number of cores.
Yeah.
So if you are running on a container or something, you have 2
One.
cores,
Yeah, one
one
or
two
two, yeah,
cores,
yeah.
and that pretty much very soon becomes a bottleneck.
Yeah.
Right? And then you have to figure that out, change it. That is a lot of work. Right? And so for Go, it's never the case. Right? Go is very you what you see is what you get. Right? So yeah, simplicity, efficiency, is some of the reasons we like Go, especially because
And
of
you
very
use
concurrent
it
Go.
like across everything, or you're also using other languages for different things as well?
So we use a lot of Python in the analytical or the data aggregation side of things.
Okay.
Spark and Python,
Uh-huh.
so where we are computing, let's say, tick prices, and we
Yeah.
are evaluating aggregates on top of those.
Okay.
So that's where Python is really shines, because you got so many inbuilt libraries. You can cook up a pretty elaborate application very easily, right? So we use Python in those cases, data science and the data engineering part of the stack. And there actually what we care about is throughput rather than latency, right? So processing of each individual record is less important as much versus processing a bunch of data together.
Yeah.
So there we use Python and Spark. Yeah, so that's the stack.
Yeah, I think number operations, there are a lot of libraries also in Python. Like the ecosystem is
Yeah,
very mature
NumPy,
for
very mature, very mature libraries. It's very easy to do those things.
Yeah. And Go, how has your experience been in building a team around Go, like in the Indian tech ecosystem right now? Like,
it's a good question.
Yeah.
I think I started using Go actually in GoIBibo. This was 2014-15 time frame, and that time Go was even more new. And what I see is, if you are a programmer from the C, Java, or even Python worlds, it's very easy to see or have a native easy mental model of what the Go constructs are. Right? So you very
a lot
quickly,
of people being in college and all this start with C and
correct
structs and pointers. They have some idea rested C like syntax. So
correct. So it's a pleasant surprise if you're coming from C, because you don't have to do mallocs and all those things.
Yeah.
Things are garbage collection is there for you, and you have all these parallel constructs. If you want to run something in the background, you just put Go in front of it, and magically it runs somewhere in the background. So and if you're coming from Python, you also get some sense of familiarity to the syntax, type inference and stuff like that. So what I've seen is, if you hire good programmers, they very quickly, the learning curve of the language is small compared to, let's say, you're going to code in Java, as we discussed, right? Even if you have done some course or some worked on it in side projects, actually coding a production quality Java service is quite difficult versus coding it in Go. In Python, you get other constructs, other problems rather, like if you, so the performance and all, if you write a 3-level nested loop in Python, it's going to be pretty slow, right? And so for Python programmers, it becomes a delightful experience to see that what was the similar setup what they used to write in Python, when they write it in Go, it suddenly becomes super fast, right? So so if we just hire engineers who have good computer science skills, for them the learning curve is not that great.
I think I've seen a lot of startups getting started. I think probably not these days, but back in the day with PHP. These days, starting off with Node or with Django, these kind of stacks. But beyond the scale, they move towards Go.
And I think it's a right evolution, right? If you have a great idea, you really don't want to hire front end back end teams. Something
with
like
Node kind of stuff.
Node kind of stuff
you
really
get started
works,
quickly.
Django is great as well. Batteries included. The entire, you don't need to write database queries. You just have a ORM, and you just say, this is my class. You persist it, and it generates the whole the whole code structure and all for you.
Yeah.
Right. And it works for a pretty long time.
Hmm.
Right. Till you hit a inflection point in your scale.
Yeah.
Where then you start fighting, and you don't need to change everything after that as well, right? For example, Goibibo, we had a Python Django stack, and we didn't change the booking part, the core transactional thing which was written in Django and Python, right? We didn't touch it because there was no need to touch it. Because by the time, a typical funnel, the transactional flow with the scale that it had,
As the bottom of the funnel
does
not scale a lot.
Does not need to scale that much. So we just kept it as is. The other parts we could rewrite in a modern
search
language.
And all of that.
Exactly, search had to be taken out and rewritten.
Right.
So you can go to a step. You can, in your journey as a company, you can go to a step A, and then pivot from there.
The other couple of questions I have, and especially tech, and then how you run the ship also, you can get there. But so what about infra? Like, are you a believer in this thing, like mostly managed services, or do you own your deployments of like databases, queues, these kind of things? I think a lot of people have different philosophies on what works for them, and I love picking their minds on what kind of a model works. I've worked with people who are a big proponent of like always use managed services. I've always also worked with people who are like, you should always just run your own or roll your own on a VPS kind of thing as well. So how do you look at infra?
So at a base level, I have a healthy distrust of a black box. Right?
Okay.
So if there's a black box, I know someday it will bite me, and that has been there even with the best of the clouds that we use. I've seen that a small thing come back and bite us, right? So, but that said, at the scale at which most like we operate, we cannot do everything ourselves. So we have to leverage managed services, right? But so we have actually a two parts of our architecture, right? One is the core trading flows, right? That we manage the infra ourselves, which is the low latency, high reliability part, the order placements and the UDP feed part.
Right.
The machines, the network, everything is hand tuned by us.
Okay.
Right, and monitored by us.
So network ingress egress, are you?
Yes, we have WAFs, firewalls,
all of that. Okay.
All the switches, the top of the rack switches, everything is monitored by us.
Nice.
And we make sure things are, we use virtualization there, but that virtualization is something that we control, the patching and everything, and we understand what's going on. And then we use AWS as the other for the vast other majority of the stack, right? So this is, I would say, hardly 20%.
And that's 80%. That also runs in a more controlled environment.
So in AWS it's a VPC. It's a virtual private cloud.
The part that you are managing, I'm saying, that is in a more controlled space.
It's a more controlled space, right? Because for us, latencies are very important. Reliability is very important. A switch dies, we want to make sure it's not a single point of failure. Because if something can break, it will break. Right? All you can do is handle the situation when it breaks.
Right.
And with a handcrafted setup, is much easier to do. Let me give an example, like logging. Right? Many people use log shippers. You log something, and the logs get shipped to a logging cluster where you can see the logs and dashboards, product analytics sometimes. Right? Now, in ECS, which is on AWS, if the logging components for some reason cannot get connectivity to its remote peer, then it does a back pressure on the person writing, which is your application. So your application gets actually stalls. Right. So this is the default logging config, by the way. Amazon have put a KB on that saying don't use it for high scale. But these things, if you use it, batteries included, these things get glossed over, and it hits you when your traffic is at peak. And you have very limited time to react. So when we use managed services, we make sure we understand at a high level at least how things are used, how things are actually happening underneath it. Right? So if you use RDS, if you use Postgres, MySQL, we understand how MySQL works, right?
Yeah.
In RDS, it's just a managed
Yeah.
version of that. So that gives a little bit more level of confidence.
Right.
The second one is monitoring, whether all sorts of things, whether we can see what's happening inside the black box of a managed service. If those things are not available, then it's a no from us in terms of using that managed service. So we are very picky as well in picking out the managed services, what we use and what we don't use. So for example, for messaging, we use handcrafted Kafka clusters.
Okay.
We don't use Kinesis and a lot of the other managed versions of that, because for Kafka is very important for us, and we tuned it for our use cases.
Right.
So for us it's very important to understand what's.
And the consumer facing part of the cloud is on AWS, and your
so there are two
core
different API endpoints, right? For the buy sell transactional part, those that DNS gets mapped to this private data center.
Okay.
Right. Whereas if you're watching charts, portfolios, recommendations, advisories, all those API endpoints land up into AWS. Those. So there's no routing at any point.
Understood.
The app talks to two different systems based upon what you're doing.
Got it.
And that's where Kafka comes in actually. So if you buy sell something, we send that event over Kafka into AWS, where some things on AWS does the churning and gives you a reflection of that.
See the final result
of it as well.
Got it. Yeah. So apart from infrastructure, the other interesting piece that all I was curious about how tech teams operate is the operational readiness part of it, right? I mean, obviously being a trading platform, a lot of things are mission critical for you, right?
Right.
So what are the run books, what are the playbooks, what are the rituals that you follow to, handle, failures, sev1s, those kind of things, and what's the, I would say, the team culture going into these issues?
Sure enough. So to start off with, right, so we have segregated experiences into P0, P1, P2. So P0s are the super critical,
right?
Mission critical services, right? So for that, we have before go live, we have a specific set of gates that the code base needs to go through.
Okay.
One is obviously the few functional tests to make sure the functionality works as expected. Then we have regressions to make sure that you didn't break other things. And then we have a full-fledged PQA environment, performance testing as well. So where we test the whole system at a relatively high TPS.
Right.
So it's a much less beefy infrastructure compared to production when run it on production. But we test, for example, each a subset of the production at peak load.
Okay.
So let's say 1/3 of the hardware at 2x of the load, something like that. So we test out not just the compute, but the database connectivity, database connection levels, caches, and messaging, and all those kind of things work at the scale. And these are all automated.
Okay.
So you have specific teams doing that, and the developers basically, as the PR gets merged or the PR is ready to get merged, this becomes part of the CI/CD pipeline as well.
Okay.
So the build gets generated, the test runs start, and then you start getting the results, etc. Right? So this is before it goes live.
Right.
Then we have before, so this after it gets live, so we don't have a fully, for the P0 services, we don't have a fully automated CD deployment. So once you complete so you once
that should be manual.
There's a manual check gates there. So there's a review which happens twice or thrice a week, and then we basically say, okay, there's a peer review. So basically a peer, let's say principal engineer reviews a deployment of another team and make sure all the checks have been done. There's some questions being asked saying, have you taken care of your dependencies, things like that, right? And once that is there, then we do deployment. We do deployment in off market hours, so that's typically after midnight.
Okay.
So and market typically the activity starts opening at 8:30 a.m. Right. So that's where the deployments are handcrafted. Even though we have ability to drain servers of load balancers and update them. We don't do it unless there's a hot fix which we need to do.
Understood. Yeah.
So this is like a normal deployment cycle. Every day from 6:30 to about 9:30, 10, there's like a running call where if you have done deployments the previous nights, then the all-con engineers
need
of
to be
the
on
team are on it.
So
Obviously,
market opening time, peak.
the market opening times, because there's a lot of things which happen before the market opens. A lot
Mhm.
of things get pre-computed and loaded onto the
Hmm.
core trading systems, and there's very little lag time there.
Hmm.
If something fails, then we have very little time to recover. So that's
Hmm.
why we don't call people.
They are already there
They
on
are
the-
already there on
the
the
bridge,
call.
yeah.
They're already there on the bridge. Make sure things are working fine. And 9:30, the peak is at 9:15. There's a very steep ramp of traffic.
Do you have
to
like a checklist and kind of thing?
Yes, so there's checklists. There's a Slack channel where every engineer keeps updating status as things progress, as they do checks. There are a few QA engineers on the call as well, right? And then 9:15 the peak is there, and after the peak is through by 9:30, 9:45, generally we know that things would be fine with the new change that we have done.
Right.
So this is mostly on the backend side. On the front end side, besides this, we also feature flag everything. Because it's very difficult to update a hotfix on the front end side.
Yeah.
So every app release that we release which touches this P0 flows, we also have a feature flag which turns it off. And then because of this, we have to do QA pretty much twice with and without the feature flag. But the ability it provides us to quickly roll back is invaluable, right? So we do the same for the front end side of things as well. If there is an issue and there's then the NOC team basically starts paging out people. So let's say at 10:30 or 11:30 there's something which is noticed, then it starts paging out people, right? And they have clear run books. So we have Grafana for monitoring and alerting, and we basically have trend lines. The best way for us to figure out if there's a problem or not is a trend line.
Something not on the trend
not actually happening as it should.
Yeah.
Right. So for example, customer logins or ad funds. At any given point in time, we know what a TPS looks like.
Right.
And if the TPS changes, if it's more or less, then we know something is abnormal.
Yeah.
Right. And we have two trend lines basically. Yesterday. So today is obviously what is happening today.
Yeah.
T-1, what was happening yesterday, and what was happening last week. Okay. Because some of our traffic is also weekly seasonal. Because on expiries.
So T-7.
T-7 also is something that we have. So, and if those graphs deviate from each other, then basically there's automated pager duty which kicks in, which calls people, and then people join the call, start looking at logs more frequently and things like that.
Nice.
So that's how things are right now.
Got it. And a question about like the building the team itself. And you have built quite a sizable team. What's the tech
right
team
now
size?
We have about 300 odd people, engineers.
Right. So specifically for the kind of shop you're running, it's fintech, heavily regulated, you have very little wiggle room for errors. What is that you're looking for also in people who are joining? Obviously, I mean, tech skills for sure, but apart from that.
Yeah, so from senior engineers, right?
Yeah.
We expect a certain way in a way they go about exploring the problem and the solution, right? And so you generally need to go from the why to the what and then to the how.
Yeah.
And one of the biggest problems is if you start going into the how, right, and start making assumptions, then those assumptions will start breaking in production. Right, and it's the responsibility of the senior engineers to surface out those what is actually meant behind the scene of the product requirements, because though products folks do write PRDs, but you need to ask those underlying questions because you might miss out certain things. All right, so we explore this in a system design round, right? So you have a very ambiguous problem statement, right? And then what we expect senior engineers is actually to spend some time in the problem domain, understand the problem, why we are solving it,
right,
and stuff like that before going into solutioning. There's no right answer in some of those questions, right? But it's just a systematic way of exploring the problem space and the solution space is what we are keen on. All right. The other part is also reliability, and how much into details have you gone in your past projects, right? Whether you've glossed over things, right? Things like those, and in different engineering levels, obviously you have different levels of expertise that you've gone into. But let's say you used a database, we ask questions like, why did you choose a funky new database versus a traditional database? Most people say, I read it in a blog or something, which is not the right thing to do. Because unless you really understood what you're using, it will break at some point in time. So how much detail do you know about the building blocks that you're using to craft a solution is also something that we closely look at.
Got it. And so currently, if folks who are, let's say, coming in and joining, what are some exciting upcoming things you are building right now? What's to look forward to?
Sure. So we deal with very high scale, right? So some of the features that we talked about is something that we're actively building on. We'll give a wide, starting with something that we talked about, right? The conditional, we're calling it conditional orders. It's live in some form already.
Okay.
Last week. Basically, it allows people to express their intent, and then the system fulfills your intent instead of you manually searching. The journey that we talked about. You load your watch list, wait for something that you want to happen, and then take an action. So this captures your intent, and we let the system actually work on the intent, right? And this obviously needs, even regulatory, it needs a sign off from you. So you can't just do it fully automated. But let's say you want in a simplest way, a pricing alert, that when something crosses, and the right now the options for you are very limited. You can say when HDFC crosses, let's say 1500,
typical AMO kind of orders, right?
Yeah, this is like a pricing alert.
Pricing alert, okay.
First you need to know that there is an opportunity.
Okay, just the alert itself.
Just the alert itself.
Okay.
Like, right now people can set very naive alerts. Saying, you tell me when HDFC crosses 1500, right? But what do you know if 1500 is the right price or not, right? So let's say you up level that, and you don't know, you are not very conversant with HDFC. Let's say you say, I want to know if HDFC is the right buy price point now or no. How do you do that? So
even let's say 52-week high or something.
Exactly, right? A common way is to see the average price in the last, let's say, 5 days versus the last, let's say, 1 month. If the average price is moving more than the last 7 days, then there's an uptick in the trend, right? And you want to buy. And the reverse, you want to sell. So you don't want customers to find it out. What you want customers is to express that intent.
Correct.
Give me a buy signal. So translating that into constructs where we can actually do alerting on, building that whole distributed system is something that we are working on. And this, in this can actually get more and more complex as well. Right. So for example, you might say, I have 1 lakh rupees, I want to make 20% profit, and I'm okay with let's say 10% loss. Okay. Just say this, and we'll figure out what are the 5 options for you. Saying these are the 5 options for you. What do you want to do about it, right? And then you choose that.
You can authorize and after looking at the options.
Exactly. You look at the option, you authorize it, and then you say, okay, I want to try this out. That itself is the next level of complexity. Right. And then we are working on things like, even higher level, like what we call fundamental level. This is all technical level indicators. We're talking about prices and stuff like that. But we also want to capture some of your other ideas. Let's say you feel that, let's say the summer in Bangalore is going to be very hot. Give me an idea for investment based upon that.
Okay.
So you have a hypothesis.
So maybe AC brands you want to buy or something like that.
Exactly. AC brands, so ice cream companies and stuff like that.
Right.
So this needs fair amount of NLP. And
I think some crypto companies tried doing things like that. I mean, there it's less regulated, so wild ideas like this.
Correct.
I had seen some like you tell, like this event will happen, so based on that, what kind of things I can
Correct. Right. So it is complicated, especially working in a regulated environment. So you don't want to cross that boundary, but we still want to allow people who are new to all the different signals and who have limited time to still express their creativity into a strategy. So how do
Right.
you convert that, right?
Right.
So fair amount of ML is involved here,
Right.
right? So to even figuring out your intent,
Hmm.
translating it into what options it is might affect, what instruments or stocks it might affect. The summer is hot example, and then figuring out whether it's a positive or a negative sentiment on that particular stock.
Okay.
Right?
Yeah.
So we need to understand what you mean first,
So-
then what a company does, what is doing right now,
Yeah,
or is
yeah.
going to do in 2 months, based upon their profile, their news clips.
Whether your prediction translates to an upward trend or a downward trend.
Correct, and a lot of news which keeps
Hmm.
coming in, right? Because there's a lot of fluidity here as well,
Right.
right? And then doing the matching,
Hmm.
and then giving you a strategy for your summer is hot theory, right? Those are things which are pretty cool for us. Since we spoke about ML, so we use a lot of the LLMs as well. We're exploring a lot of the LLMs.
Yeah, I mean, that's the question I was definitely going to ask, because these days, everywhere I see companies are doing internal hackathons, asking people to try out some of these Gen AI tools and all to see what they can do in the product. Is there something that you have also played around with?
Yeah, so we have an initial POC for the most the use case which comes to mind very quickly is customer support.
Yeah.
Right, customers keep asking queries,
Huh.
emails or phone calls and all, and you want to answer them without human intervention. That's how you scale.
And do it quickly. Yeah.
And do it quickly as well, right? So that's where we tried our first POC, and a lot of learnings there. But once we actually kind of got it in the right config, it was actually able to almost, I think the accuracy rate with a human, we done it in the shadow mode. So we had our call center and the AI assistant run in shadow mode. The accuracy in the even 15-20 days of the POC training was almost 75-80%. So whatever human could answer, the AI assistant could do as well. But we had to do some tuning, right? The primary problem with our space in using a generator or transformer model is, so the transformer model's knowledge is baked into its parametric memory, right? You have trained it a billion parameters, and it's been trained on what is available in the on the internet as well, but that is dated. Right, it's probably when it was last scraped. You build your knowledge on top of it, and also doesn't have a lot of context on real time things which is happening. Like if you placed an order, someone says, what is happening to my order? It doesn't really have context, right? So there's a technique called RAG. Facebook invented it, I think, or wrote a paper on it in 2020, which we're exploiting. So with RAG, we try to marry this LLM's amazing capability of capturing intent and giving answers,
plugging it into APIs which have real
exactly data. Right? So and the question is, when do we plug it in?
So I think Google, Facebook, they both were doing those things like API.ai, with.ai around that time. I think they published those papers, Dialogflow and all.
AI was pretty ancient, but it was
in that direction that turn the NLP into intent and then process it into some API
flow, and which they would call us to ask us, hey, what's really the status of the order. Right. So here with working with LLMs, you have to a little bit turn it around. So you need to tell you need to ground the LLM into saying that here is some context,
right,
and use this context while making inferences.
Okay.
Right. And over the context overrides anything you might have in your parametric memory. Right? This is what is giving us good results.
Got it.
So even for simple things like trading holidays, let's give a recent example. Because of the Ayodhya temple, there was a holiday declared.
3 days back. Declared,
actually, it was declared the day before. That Saturday would be working and Monday would be off. Right. So that context overrides what was scraped earlier on, that
what a trading holidays,
what a trading holiday was.
Mm-hmm.
Right. So and we just started this journey, but very interesting things.
If somebody comes to support and asks, is tomorrow a trading holiday, and then a wrong answer obviously is not
yes,
a
it's
good
not
out.
it's not great, right? And nor is the answer. Another thing with LLMs we need to actually be careful about is when do you say I don't know.
Yeah.
Yeah, because if you
Confidence factor is a problem there.
yeah, because if you just let it run, then it can hallucinate.
Yeah.
Right? It's because it's just figuring out the next the token in the set of language tokens that you have. It tries its best to figure out its token, right?
Yeah.
So
I mean, it's always generating text. It does not know about its knowledge capacity in any way.
correct.
Yeah,
And when do you say I don't know, right, is actually a better answer than giving a wrong answer.
Yeah. And then you can fall back to human agents if you have that signal.
Exactly. And then you can fall back, right? But if there's no fallback signal to us as a system,
Right.
then we let a semi correct answer go to the customers.
Right.
So that also involves we are experimenting on that, figuring out how we can right from tune LLM which is already available as a service to actually training it ourselves. So there are some people in Bloomberg has trained its own LLM with a lot of fine tuning in terms of tokenization and other things for its use cases. So that's the other extreme, which involves a lot of investment and
I mean, build your own parameters. That takes months of training and
months of training. It's heavy in terms of cost and computes and other stuff, right? So we want to see the RAG thing is pretty good for us, right? How we can build around a open source LLM while solve some of these problems that we mentioned. That is an interesting areas for us.
Cool. One final question about the Gen AI space, more in terms of the developer productivity itself. So I mean, GitHub Copilot and obviously beginners are also a lot of people learning to code from ChatGPT. But more than the learning to code part, I would say that already seasoned engineers in your team, are you trying out like something like Copilot and seeing any productivity benefits out of it?
Yeah, so we are trying out Copilot. Actually, we work closely with Azure and Microsoft on that. We are running POCs, and because it's such a reliability heavy domain, we want to go slow on this, right? Because we don't want just people to use auto generated code live in production. So we're starting with things like automated tests.
Okay.
Right? And then let the Copilot fill out the actual test function code.
Okay, got it.
While writing the high level outline, right?
To generate the instrumentation code, part of the code.
Yeah, the functional tests and the performance tests and all. We want to test this API. So it's pretty so the LLM,
that's safer because that's
exactly.
not production code, it's only for
testing. It's a production enabler code.
Enabler,
Right. So on the code trading paths, I think would be the last parts where we have automation, because it's pretty handcrafted, and we really eyeball a lot of the details. But I think we are seeing pretty good results. The other part we worry about is IP as well. We don't want someone's other IPs to leak into our code as well.
Yeah, that's a problem.
Yeah, that's a problem as well. So we are a little careful along those lines.
That's really nice to hear. So a lot of great answers. I think I was curious about some of the internal workings of a trading platform, and then a lot of those curiosity also got satisfied. On a parting note, any message to people who are starting out their career in tech? Especially, I think last few months, maybe a year, has also been a little tough in the tech market because from the employment perspective that's there. Also, like AI tools and all helping improve productivity. So I think a lot of people have a lot of questions around, like, if you're starting out a career in tech, what kind of things people should think about, keep in their mind. Any advice as a parting note?
I'll try my best. I think it's very difficult to predict the future, especially at the pace at which things are changing.
Yeah. Fair.
What I feel is, so there will be some parts of the tech ecosystem which can be fairly automated, right? Or with AI or other places, like writing low level code. At some point, it's going to get pretty commoditized. Right?
Yeah.
but translating a set of ambiguous requirements into basic building blocks.
Yeah.
Right. I think that will take some amount for it, for us to be totally relied onto an automaton, if you will. Right. So the space is there. So I feel the building blocks would just change. I think if you look at way back, people used to write code in assembly. Then they started using C and started getting higher level abstractions to work on. So it will be a journey like that, where the abstractions will get more and more fatter.
Yeah.
Right. So
But that's still like the what to how layer, not the why to what layer.
exactly. Right. The why and what is where a lot of creativity and I think human intelligence would be very difficult to replace in the near term. Right. So even if you are a small startup, you would still need like a, for lack of a better word, an architect or a principal engineer.
Yeah, who can do the why to what translation. Yeah,
exactly.
yeah.
Right. So that space is secure, I think, for at least a foreseeable future.
Right. And I think like people who are starting their careers, they should also focus on that skill set also.
Yeah, I totally agree. So I don't think, for example, it's a pretty, like, I don't think prompt engineering is a great, I don't think it's a great idea to do your undergraduate focus on prompt engineering, for example, right? I think it's there's not much differentiation you can do there. Stick to the basics of computer science, right? Distributed systems, those always will be key, because finally, even when you're using a higher level building blocks, you want to know what's happening underneath. Even if you don't know the details, you need to have a good mental model of what this building block is doing for you. Or if in the case we described, right, someone is filling out the code for you, you at least need to be able to understand what's written and figure out whether it's right, wrong, right, for you. Yeah, I think one of my friend, who mentioned this once to me, right? Do ML as the great engineer you are, not the great data scientist which you ain't. Right? So I think engineers, the engineering skill will always be there for the foreseeable future.
Nice. Thank you for this I would say summarizing advice as well, and for all the elaborate explanation of everything that you are doing, and these new decision models you're talking about. I hope you guys build them and make probably trading even more fun and creative venture. So all the best for that, and thank you for taking out your time. It was nice talking to you.
Thanks, Arnab. Likewise. Nice talking to you as well.